Now to the furthest left you see the risk of tipping points in ecosystems, and right here you have the risk of so-called large-scale discontinuities. So simply put, human-induced climate disasters. Now the knowledge base 2001, as you see on the disaster point, was that not until 4 degrees warming on average we may risk the kind of disaster change such as destabilizing the Greenland ice sheet, such as destabilizing the West Antarctic ice shelf. Now look at the right-hand side, which is the knowledge base 10 years later. So this is science understanding more and more about the complex, adaptive, self-regulating Earth system. And the more we learn, the redder it becomes. So the more we understand of the impacts and the function of the Earth system, the larger seems to be the risks. And that's the warming so far, and if you push again on this, that's the so-called safe 2-degree target. That's indeed a very unsafe target. And the interesting thing is that there is, of course, uncertainty in climate science, we'll come back to that, but one thing that there's very little uncertainty about is the sensitivity of the Earth system. There's increasingly robust knowledge that 2 degrees, in fact, will create major, major problems for human societies. And then we go through the science of climate change, and we don't have to put much effort there, apart just for showing up in the left-hand corner you see the observational evidence, the maps you may have seen from NASA, that 2005, 1998, and 2010 are the warmest years on record. And this is the famous map from John Sheldon on what systems in the climate system could tip under pressures from human-induced climate change. We then, of course, and I think we're doing that in a way that often science is not very good at. So if we on the one hand conclude that there's little uncertainty with regards to the danger of 2 degrees, little uncertainty. We know as a certainty that it may, for example, have a high risk of undermining the marine ecosystem in tropical regions. But there is an uncertainty in this very famous graph, which is, as you know, the engine of all global climate models, namely the climate sensitivity. How much average warming can we expect at a doubling of the concentration of greenhouse gases? Now this is just a frequency diagram of the big models, and as you know, the IPCC concluded that on average, we can expect a 3-degree warming at a doubling. Now doubling is interesting at this point in time, because we're heading towards a doubling. We are at 450 ppm, and we're rushing towards 550, and doubling is 560. Now, the trick is that if you take more recent science, and if you include what is called slow feedbacks, the sensitivity goes up to 6 degrees. So we have an enormous uncertainty when it comes to the sensitivities. We have little uncertainty in the impacts on societies, but we have an enormous range from 2 to 8 degrees of uncertainty when it comes to how will the planet react to our energy disturbance. Now Anders and I concluded in the book, is this a problem? We say no. In fact, it's a very little problem because the uncertainty range goes from a dangerous future, 2 degrees, to a totally and utterly disastrous future, 8 degrees. And therefore we are entirely in a large uncertainty zone, but a spectrum of action, which, as you all know, climate deniers uses all the time as a way of, so to say, portraying that science does not know what the risks are. Now, if you translate that to what we need to do, the picture becomes tremendously more dramatic than the climate political discussion as we see it today. As you know, even the most ambitious dialogue today is a potential reduction of global emissions by 50% by 2050. This is a very important summary of the science that came out before COP15 even. It's already 2 years old soon. And it shows in blue that if we're able to bend the global emissions curve on fossil fuel emissions by 2015, and nobody believes that it's even close to possible, we need to decarbonize the world by 2050. Decarbonize the world by 2050. If we wait until 2020, we'd actually have to decarbonize by 2040 in order to have a 70% chance to stay under a dangerous target, 2 degrees. So that is a denial, that there is this enormous rift between the knowledge base, which is becoming more and more robust, and the political discourse, which often even refers to science when it defends, for example, that 450 ppm is safe, that 2 degrees is safe, that 50% reductions will be enough.
Then we spend 2 chapters on what we call the merchants of doubt. In Swedish, we talk about med tvivlet som vapen, eller med tvekan som vapen. And that particular title or expression goes back to a fascinating book by a science historian by the name of Naomi Oreskes, American. She came out with this book about a year ago, Merchants of Doubt. And she has gone through, well, she has studied really a number of important issues over time since the 1950s. The debate on the risks with tobacco, acid rain, the ozone layer depletion, and now climate change. And what she concludes is that there has all the time in the US, in America, been very strong groups of people financed by industrial interests, but also by extreme think tanks that have tried to block legislation and political action. Not necessarily by saying that the risks are not true, rather just saying the issues are not settled. There is still uncertainty. And as long as there is uncertainty, we cannot impose on society costs without knowing more. So we've tried to really understand what motivates these people, and to some extent it is industrial interest, the fossil industry of course in terms of climate change, but there is also a lot of ideology involved, no doubt of it. And there is in America quite a lot of research coming out showing that people who look upon society in a way where any regulation of business is seen as a threat to freedom, they have a tendency to dismiss information from science in these areas. So it's quite interesting. We don't have much of this in Europe, and we don't spend much time on the so-called climate deniers in Sweden. You have the Stockholm Initiative and a few other groups, but we know very little about them. But in the US, there is a lot of knowledge, and we know for one thing, they have blocked legislation, and they are effectively blocking legislation. We also go into detail and try to identify the different actors in the climate debate. And we have come up with 6 different groups or categories. One is the kind of people like James Lovelock who say, basically it's already too late. There's no way we can stop climate from destabilizing further and further and further. Then we have the group of earth science, system scientists like Johan Rockström and his colleagues, which to some degree agree with Lovelock that it's late, but that there is still a possibility to turn the tide. Then we have IPCC mainstream, which is IPCC of course, and many governments. Then we have people like Björn Lomborg who say climate change is happening, but we need to do nothing or very little, because there are other problems that are more important. Then we have the climate skeptics, and then the deniers, like these institutes that I referred to. And then we deal quite extensively with the kind of arguments being used by those who deny there is a problem. And we don't have time now to go into detail, but you can just look at this. Either they say that global warming is not happening, or they agree it's happening, but it's caused by natural variation. And those who don't agree that it's happening, they say that even if there are several independent temperature records, these are manipulated. That's a big thing. That all the temperature records are being systematically manipulated. What a conspiracy. I mean, I don't think it would be possible even if you would try it. Because how can you keep something like that without being disclosed? Global warming is caused by the sun is another argument. Sea level rise records are manipulated again, glacial mass balance records are manipulated, etc., etc. And then we go into some of these specific claims, and I think we can very convincingly prove that they are wrong. And I don't think we have time tonight to go into the detail. Those of you who are interested, you can read for yourself. But we have here a whole series of graphs that demonstrate, for instance, you can see on the right hand the glacier mass balance. In fact, some of the glaciers in Europe were increasing in mass during the second part of the 20th century, but now even there they're going down. And it's not so strange. I mean, if you have more precipitation in areas which you have when you have a warmer world, if that happens in areas where it's still very cold, of course, you have snow and you have ice. But as you can see, glacier mass balance is being reduced dramatically now all over the world. And
yes, I mean, one of the things that has happened, and somebody just before we started said we were so impressed that in fact you referred to some literature early spring 2011, and it's true, right at the very, very end of writing this book, we continue to see this avalanche of new insights coming in and new science. So what we flip through right here is common knowledge, I'm sure, to all of you, but what is coming out now, right as we speak, and this is just referring to some of the stuff that just over the past 2 or 3 months is in our mind very dramatic, because we're starting to see science published for the first time, for example, showing with scientific evidence the question that no scientist was willing to answer just 6 months back. No scientist with credibility was willing to answer the following question by journalists, the most common question of all. So we have another hurricane, we have another drought, we have another flood. Is this anthropogenic climate change? And you get a mic in your face, and any scientist with credibility says we cannot associate any individual extreme weather event with anthropogenic climate change. That is now history. Because just 2 months back, in Science, a full special series of articles is now showing in Australia, in UK, in different parts of Europe, that there's no other way to explain even extreme weather events without anthropogenic climate change interference. We today see the observations of the Arctic, which has no other explanation than anthropogenic climate change. You have Australia, which is perhaps the most dramatic example of all, with 12 years of drought followed by the largest flood ever, and climate scientists clearly showing that there's been some kind of flip in the way now rainfall is distributed across the east-west gradient in Australia. And as you may know, the GDP of Australia fell by 5% last year. So the prediction of the Club of Rome that global environment change would have a drawdown on economic growth appears to now becoming a fact. So we're starting to see empirical evidence of things playing out at this time step, which is something that really supports, of course, the science on Earth system change.
Yeah, and then we have a chapter where we discuss more in general, why don't we discuss climate risks in a comparable way as we do with other risks? We talk about aviation, car traffic, etc. Where if we were talking about the same kind of risks as we do in the climate area, we would stop completely from flying and driving cars. And then we move into this relatively new discussion about finite resources like crude oil, which